everybody. This is James at McLaren Engineering Group. This is Fulton Avenue in Mount Vernon, New York. We're moving the original structure that was built in about 1897. We're going to walk it 150 feet north off of the structure so that it can be broken down and demolished. What you can see here is actually the existing bearing. It's up on a Gantry System. This is their spreader beam that's on top of the gold hopper. Last night we picked the bearings up from the existing substructure, lifted it about 15 feet, and walked it north about 15 feet. Right now I'm actually standing on the skid beam system, which is how the south bearings are going to slide along the length of the structure. The north abutment is going to be pulled via the gold hopper, and the whole system kind of just works as, basically frictionless, a frictionless system. Right here is the Gantry System itself. This was it's all hydraulically operated by McLaren. They jacked it up with the hydraulics. That's the system that actually hoisted up the bridge 15 feet. You can see a couple of really big shackles up there, which we attached rigging to directly to the bearing, which was paramount for the design because the existing bridge was always supported by the bearings. So we attached the rigging around the pin of the bearings to keep the existing conditions exactly as the same as the construction conditions. You also see right here that the gold hopper is supported on this 30-foot distribution beam, which spans from the south abutment to a temporary footing that you can't see because it's buried underneath the soil. But the stability of the abutment was a major concern because that was also built in 1897, and it's comprised of just masonry that's all grouted and stuff, which didn't have a whole lot of stability built in, especially when we removed the structure from it, which is a stabilizing force. All right, also down here is a good view of all of the temporary works by Mammoet that we designed the erect plan to get everything into place to actually facilitate the slide of the structure. Over at the center pier, those towers are actually supported on the proposed foundation that McLaren also designed under the DU package. And there's a custom grillage system that prevents overturning during the slide. Also at the substructure, particularly the north abutment, we had designed, you can't see it, but we designed some custom bearings that provide a PTFE frictionless surface so that when the gold hopper is actually driving, those longitudinal friction forces don't create a driving moment and produce an overturning moment, reducing the stability of the structure. There's a few other more minor inclusions that we did to facilitate the overall stability of the structure. Obviously, we analyzed the structure in RISA with winds load and all other construction loads placed on the truss during the move. But overall, this is just a good general shot of the structure prior to the slide.
Another piece of engineering by McLaren was the design of a temporary distribution foundation behind the north abutment for the temporary works of the skid track beam. The purpose being the weight of the structure moving toward the north abutment is going to put vertical pressure behind the abutment, and distributing that force out at a distance from the back wall will reduce the lateral pressure pushed onto the abutment in its no-load condition. So it was vital to the stability of that abutment during this stage of construction or demolition.